Greetings, everyone. We're going to have a series of videos here on Chapter 6, a first look at classes. This is actually a bit of a different topic than some of the ones we've been doing so far. Thus far in the class, chapters, especially 2 through 5, we've really been looking at the syntax of Java and more basically just some of the basic syntax in programming. You've got, while loops, if-then statements, and so forth. But now we're getting into some bigger structures about how can we actually create classes, which is a way to kind of codify the behavior of all these different smaller pieces that we've been learning. How can we organize it? So first thing we're going to look at here is the difference between an object and a class and how we can create them. First of all, an object is something that is actually in memory right now, and it does something. Objects generally can do one of two things. They essentially have nouns and verbs. So the noun piece, they can store data, and the data they can store is generally known as fields. So we're going to take a look in a few minutes at a rectangle example. A rectangle's properties or fields would be the width and length. Objects can also perform operations. And those operations or verbs, those things are known as methods. So in the case of the rectangle example, we would have maybe set the area of the rectangle. Or maybe if it was something that we were going to draw, we could set its color. Now the color would be a property or a field, but setting the color, or doing some kind of action on the rectangle, moving the rectangle, for example, that would be a method. Thus far, we've already used objects. We've got the scanner objects for reading input from the keyboard, the random object for generating random numbers, and then the print writer was something we were using to write files. Those are things that exist within the greater Java library. But sometimes we want to have some behaviors and so forth that obviously don't exist within the general Java library, and so we have to write those. So that's essentially the beginning of the conversation that we're having now, is how to write our own custom objects and classes. So when we need a particular object, we instantiate that object into memory and then call the object's methods. So a class is where the object comes from. The class would be code that we write that describes a particular type of object. The class we could think of as the blueprint for the object. So we write the class, which is obviously basically the topic of this chapter, and then when that class is instantiated into memory, it becomes an object that we can use. Okay, when the program's running, we would essentially grab the class, and we can see the syntax of it here in a moment of how that looks. And we can have many objects created from one class. For example, the rectangle class. We might want to have a small blue rectangle, a medium-sized green rectangle, and a large red rectangle. So in that case, the rectangle class, would be instantiated into memory 3 different times, one for each of the instances of the rectangle, the blue, the green, and the red. Each object that's created from a class is called an instance of the class. So in this example, we've got the scanner. You guys have used this line of code quite a bit. We have on the left a variable called keyboard, and we have on the right we reference the scanner object, and we essentially assign that object that we're instantiating or creating in memory to a particular variable, in this case the keyboard variable. Same thing with the random class. You can see there's pretty much a pattern. We have a variable on the left, and the object in memory is referenced on the right. So we create the object in memory using a particular syntax. And in Java, it's going to be we use the new keyword and then assign that memory location to a variable that we pick. Same thing with the print writer class. The unique thing about the print writer class is, of course, that there's an argument inside of the parentheses for the print writer class. You notice that for the random and the scanner, well, the scanner has one. It's the input. In this case, the keyboard, the console. But the print writer, the argument that we enter in there is the name of the file that we are going to write to, all other being the same. The object is instantiated into memory and assigned to a variable. So we've we've dealt with those three classes thus far. And next we're going to talk about creating our own, and that's essentially the topic of chapter 6, is how do we create our own. So again, we're going back to a simple concept, a rectangle object. We're going to give it two properties or fields, the length and the width of the rectangle. Then we're also going to assign the following methods. Now these are pretty simple methods: setting the length, setting the width, getting the length, getting the width, and then getting the area. So pretty simple. It's not that the rectangle really does anything. This rectangle class, all it's going to do is we have the ability to create it, set its length and width, and then retrieve those values. So the way that's going to look is we're going to create the class, public class, give it a name, the rectangle. We have our curly braces. And then internally we have some private variables that are going to store our length and our width. But we need the ability to actually have the user set them. So when something says private, when a variable is noted as private, that means that that variable is not accessible outside of the container of that class, meaning that a user who's accessing the rectangle class via an object in memory cannot see those private variables. So we are going to need to give them access, and we'll do that using the set width and set length methods. So we've got our access specifiers. We've got public and private. And this is an interesting topic that's kind of a more generic topic about programming, is that when we are dealing with objects, there's a more general sort of conversation about object-oriented programming. One of the things about object-oriented programming is that we can encapsulate the inside of an object. So we may have private methods, private properties inside of an object that the user doesn't know anything about, and we can change those internal workings of an object without breaking or interfering with how that object behaves with other objects. So that term is called encapsulation. It allows, when you're dealing or exposing an object, you want to be very careful about those public things that you've made available to users. But the private things that are only inside the object can be changed by the programmer without breaking anything. Okay, so we've got a public access specifier that if it's public, if it's noted as public, the member can be accessed by code inside or outside the class. A private obviously can only be accessed inside. And so when we're defining a method, we've seen this before. We've already had a section on methods, but this is a quick review. We've got the access specifier, could either be public or private. The return type, void means there is no return type. And you can imagine, you can see that if we're setting the length of something, the return type is empty because we're not getting anything, we're setting something. So in this case, we're setting the length, and the input is a number, the length. And you can imagine when we get the length, it's going to be exactly the opposite. The return type that we're going to get is a number, and the argument that goes in is going to be empty because we're just going to be getting a value. In some cases, we may have methods where there's an input and an output. For example, if there was a property that said, get my social security number, and you had to input your name, the input would be the name, and the return would be a string or a number that defines the social security number. Okay, so the setLength method, we have the signature at the top that we just looked at, and then we are going to take that inputted length, len, and we are going to set it to our internal length variable that we saw a few pages ago. There it is. It's a private double length. That's the internal value of the length of the rectangle. And really that's all we're doing in this setLength, is we're just assigning a user value of len to the internal length. And then you can see the syntax for creating a rectangle object is basically the same as that for accessing the classes that we are already familiar with, the Java classes. We have the class type, the rectangle, the variable, which is box, and we use the syntax of new to indicate that we are creating a new version or a new instance of the rectangle class in an object. When we instantiate it the first time, we haven't set the length or width yet, so whatever the default values are, those are going to be set, so that they're going to be 0 in this case. And if we want to set the length now, we would use the dot after our variable, box dot set length, and then we would enter in the number that we want to set the length to, in this case 10, and it sets the length to 10. Once we've set the length, we want to perhaps then get it, and you can see the signature of that function is going to be a public. It's going to be a public function, public method. The return type is going to be a double, a number, and the input is empty because we're getting something, so get length empty parentheses. And then all we're going to do is use return, and then that same internal private variable is going to be passed back. And then finally, the getArea method is just going to return, instead of one thing, it's going to return the multiplication of length and width. So this is just a little more, an example of a little more sophisticated, not much more, but a little more sophisticated method. We have a concept of accessor and mutator methods. Methods that retrieve data, that get things, are accessors. Methods that change things, modify, update the data, are called mutators. So for us, the get length, get width methods would be accessors. We're accessing the length, accessing the width. When we set the length and when we set the width, those are going to be mutators. Getters and setters is another name for those. I probably like those better. I have to confess I don't use accessor and mutator much in my normal day-to-day programming life, but getting and setting is a pretty common way to refer to method types. And we talked about this earlier, but there's encapsulation is a concept in object-oriented programming, but the concept of hiding data, anything that's a private field or a private method, is hidden from anything outside the class. Code outside the class has to use the public methods in order to gain access to the private data. You can use the public method to pass in data, and then the class itself can use that data that was passed in to set values, like we did with the width and length. And this is important, as I mentioned earlier, that we have